lectures till now we had the theoretical aspects explained, sometimes in brief, sometimes in depth. So in this lecture, we concentrate on going through the problematic aspects of analog communications. Why? Because theory and problems both go simultaneously. Once you have got a fundamental theory, we need to apply them for real time for calculating the performance related parameters. In particular, in analog communications, we are going to have bandwidth and power are the fundamental parameters need to be estimated irrespective of the continuous wave modulation scheme. It can be amplitude modulation or it can be frequency modulation. Our objective is to solve the problems for wide cases. So before I will do this, I advise you get your calculator because I'm not going to give the final answer in this lecture. Get the calculator with you, go through the steps, and then get the answer. Okay, so let us go one by one problem. So the first one will go like this. See, obtain the carrier amplitude, message signal amplitude, carrier frequency for FM signal. And FM signal is given. Okay, given as S of t equals to 10 cos 4 pi into 10 power 60 plus 0.5 4000 pi t. So what is required generally is before you solve the problem, it's always better to write the expression. He has mentioned that a given modulation scheme is FM. So what we can do immediately, write down the FM expressions which you know. One is the standard expression for FM. AC cos omega Ct plus 2 pi kf integral m of t dt. This is standard expression, right? If you know directly which expression to use for our problem solving, that is very good. If someone were unaware of the expressions to be used, write down the expressions and then go ahead. That is one expression. Simultaneously, we have one more expression for FM given as AC cos omega Ct plus beta sine omega mt. Now, this is the given data. 10 cos 4 pi into 10 power 60 plus 0.5 4000 pi t is the given data. This expression, this data corresponds to which one of these two? Is this expression acceptable or this acceptable? We need to compare. So verify once. AC cos omega Ct cos omega Ct. Sine and sine. So this is the expression for a single tone FM signal. We need to confirm that first of all, right? So once it is confirmed, then remaining steps are easy. So what are asked? Carrier amplitude, compare both. Carrier amplitude means AC, AC. AC is equals to 10 volts. Done. Then message signal amplitude, where you can find message signal amplitude. Here it is beta. Beta is given, no, beta is given as 0.5. If you compare both AC cos omega Ct plus beta sin omega mt, beta value is 0.5. So we have to get the expression for the message amplitude through this beta only. So it is better you write down what is the expression for beta. Beta equals to delta F by Fm. We know what is delta F. Delta F is given as Kf into Am by Fm. So these are the few expressions everybody must remember because they are the fundamental basics. No, beta is modulation index. Delta F is the frequency deviation. Fm is the F suffix M is the message frequency. Come to this side. Kf is the frequency sensitivity. AM is the message amplitude, which we have to estimate, and FM is the message frequency. So after writing this now, let us go step by step. First of all, let us find out what is the message frequency. So how to write that? If you compare both the expressions, omega m equals to 2 pi, FM equals to 4000 pi. It is given. So pi cancel, and this is 2. This is 2000. So correspondingly, your message frequency FM is 2 kilohertz, right? Okay. Then what you have to further estimate? We have to calculate the amplitude of the message signal. So you have to go like this. Beta value is, let us write the expression first of all, right? Okay. So AM, message amplitude equals to beta into FM by KF, right? Hope understood. This is beta, this is message frequency, beta into FM by KF. So what is the value of beta? 0.5. What is your message frequency? 2 kilohertz. It means 2 into 10 power 3. And what is the frequency sensitivity? He has given, we need to see. Frequency sensitivity is 10 kilohertz. So you have here 10 kilohertz means 10 into 10 power 3. 10 power 3, 10 power 3 cancel, right? Okay, let us just 1 second, give me time. Okay, so AM message frequency equals to 0.5 into 2, 1 by 10. So it is 0.1 volt, right? Then what else is asked in the problem? You have asked what is the carrier frequency. So where is carrier frequency? Omega C. How much? It is right here. Okay. So in the given problem, omega C equals to 2 pi Fc equal to 4 into pi into 10 power 6. So pi cancel 2. So carrier frequency is 2 megahertz. We all know, let me not mention here, you are all quite aware, omega equals to 2 pi f. So in this manner, based on the data given, we have to choose the proper expression and estimate. Most of the time, we are going to be asked in amplitude modulation and in frequency modulation, you will be asked about power and bandwidth only. So let us see another expression. Okay, what is this? A 20 megahertz carrier is frequency modulated by a sinusoidal signal. Okay, frequency deviation is 75. What is asked? Modulation index is asked, bandwidth is asked. So let us first of all write the data asked. FC given no 20 megahertz. Then what else is given? Frequency deviation is given. Okay, 75 kilohertz. Okay, and he has asked two cases. FM1 message frequency equal to 2 kilohertz, case 1. Similarly, FM2 message frequency equals to 10 kilohertz. For these two cases, he has asked what is beta and what is bandwidth. Remember, it is FM, frequency modulation. So before you solve a problem, always, it is advisable to write the expressions. What is beta? Modulation index, right? Beta is the modulation index. What is the expression? Delta F by FM, right? Okay, so we go for case 1. Case 1. So beta 1 I will take. What is modulation deviation given? 75 kilohertz. And what is the frequency? 2 kilohertz. Right? So 75 kilohertz by 2. Count how much? It will be around 37.5. Check once. Of course, that is a 0.5. So what is happening here? Beta value is much larger than 1. So this comes under wideband frequency modulation. The transmission bandwidth for wideband frequency modulation is 2 into delta f plus fm. Delta f is the frequency deviation, 75 kilohertz, and fm is the message frequency, 2 kilohertz. So let us go. What is the bandwidth in case 1? Transmission bandwidth 1 equals to 2 into 75 kilohertz plus what is message frequency? 2 kilohertz. So 2 into 75 plus 2, 77. 2 into 77 kilohertz. So this will be around 154 kilohertz, being it is a wideband FM. Similarly, we can estimate the another one also, beta 2 equal to delta f by fm2. Delta f is 75 kilohertz and fm2 is 10 kilohertz. So again, this is 7.5. Okay, so here again, the value of beta is large. Okay, beta 2 also large. The modulation index beta 1, beta 2 corresponds to two cases. No, it is larger. So again, it is wideband FM. So the transmission bandwidth for wideband FM equals to 2 into delta F plus FM. That is equals to 2 into 75 kilohertz plus 10 kilohertz. Why? Because in the second case, the frequency of the message signal is around 10 kilohertz. So transmission bandwidth for case 2, 75 plus 10, 85. 2 into 85 kilohertz, which will be around 170 kilohertz. Hope understood. This is the number of ways. See, the first variety is different. Second variety is different. So if you know the fundamentals, you can do any example like this. Now see this case. He has not given the FM expression. He's simply asking what is the FM expression and estimate the power. So for doing this, let us write down what is the expression for standard FM. AC cos omega CT or AC cos 2 pi FCT also you can write 2 pi K F integral 0 to T M of T TT. So given now what you have to do? Cos carrier signal is given, message signal is given. Simply substitute what is cos carrier 10 cos 4 pi into 10 power 60 plus 2 pi kf. How much is kf? Okay, let me just mention that also. He has given kf also 10 into 10 power 3. Okay, this is the frequency sensitivity into integral 0 to t m of t message signal 5 cos 4000 pi t. Okay, is it clear? We have to always write the standard relevant equation first of all and then go on solving that. Say, right? So let us continue here. S of t equal to 10 cos 4 pi into 10 power 6t plus, yeah, see this one, 2 pi into 10 power 3 into 10 into integration of cos is sine. So 5 sine 4000 pi t by 4000 pi. We know now by 4000 pi. How this came? Hope you are aware. Integration of cos omega mt will be dt will be sine omega mt by omega m. We are quite familiar on the fundamentals of integrations. So now you can cancel pi cancel. This is you can cancel out this is 3 with this is 3. What is left over? 2 into 5, 10, 10, 10s are 100, 25, right? Okay. So correspondingly, the final expression for the FM signal is 10 cos 4 pi into 10 power 6t plus 25 sine 4000 pi t. This is the thing asked. What is the expression for the FM signal? And there's another bit also. What is the power? The total power in frequency modulation is always constant. Power in frequency modulation is AC square by 2. Hope you remember. In amplitude modulation, it is PT equals to PC into 1 plus mu square by 2. Whereas in frequency modulation, the total power is always constant, AC square by 2. What is the value of AC? 10. So 10 square 100 by 2. Always we need to mention units also. 50 watts. See how easy. If you remember the fundamental expressions, you can easily solve the problem. Right? Okay. Now let us just go for deviation from modulation to a communication system. See this example. Image frequency rejection ratio was asked. So this is corresponding to radio receivers. Image frequency rejection ratio is the fundamental characteristic of radio receivers. So what is the expression? Alpha image frequency rejection ratio is given as, hope you remember, root of 1 plus q square rho square. Yeah, what is Q? Loading factor, no? Q is called as a loading factor. What is rho? Rho is a value given as FSI, image signal frequency by Fs minus Fs by FSI. Right? FSI stands for image signal frequency. FSI equals to are called as image signal frequency. What is the expression? We just see here also. Expression for FSI is image signal frequency equals to signal frequency plus 2 into intermediate frequency. Now we have to calculate this image frequency rejection ratio for two cases. Message frequency is 100 mega only. Okay. So let me write the data first of all. What is Fs? Fs value is given 100 megahertz. Okay, what is required? Case 1, Q value, how much? Q value is 50, Q value is 25. So case 1, Q value is 50. Now let us solve this and then go for case 2. Okay. So what is asked? Image frequency rejection ratio is asked. So before we go for that, let us estimate what is the image signal frequency. What is the expression? The expression is Fs plus 2 into F-IF. Fs is 100 megahertz, right? Okay. Then what about the intermediate frequency? No, intermediate frequency is not given, but it was mentioned that it is FM. So for FM, intermediate frequency equals to 10.7 megahertz. Remember, for FM, intermediate frequency equals to 10.7 megahertz. Okay, so the value of FSI will be, see this, 100 mega plus this one is 21.4 mega equals to 121.4 megahertz. Right? Now, we need to proceed further for alpha. Before go for alpha, get rho. What is rho? Rho equals to FSI by, so 121.4 megahertz by Fs 100 mega minus Fs 100 mega by 121.4 mega. So get your calci outside and calculate what is the value of that. maybe around 0.390. I just check yourself. The value of this will be around 0.930. Maybe verify once. So I think it's right. Okay. So then alpha equals to root of 1 plus q square rho square. So root of 1 plus, what is the q value first case? Q value 50. So initial q value is 50. So 50 square into 0.39 square. Okay, completed. Just check the value with yourself. The value will be around 19.5. Confirm this. Estimate the alpha value. Maybe 19 point something around. Right? Check this. Right? Now let us go for case 2. Second case is there no? Case 2. What is second case? Q value is 25. So simple. Q value 25, everything is same. So alpha equals to root of 1 plus 25 square into point. How much you got earlier? 0.39, right? 0.39. 0.39 whole square equal to how much value of alpha you get? Verify once. Around 9.80. If sometimes it was asked to estimate this in dB, simply you can use if alpha image frequency rejection ratio is to be told in dB, then simply it is 20 log 10 9.8. If asked. Okay. That is about estimation of image frequency rejection ratio. So say this case. It is AM receiver. Everything is same. All difference is for AM. So expressions are same. Alpha equal to root of 1 plus q square rho square. So case 1, message frequency fs is 1 megahertz. So what do we have to do? Initially, you have to estimate the image signal frequency fs plus 2 into FIF. So what is fs? 1 megahertz. Plus what is IF? It is AM radio receiver. So 455 kilohertz. So which will be equal to 1 megahertz plus 2 into 455 is 910 kilohertz. What it means? It is 1 point. So FSI equal to 1.910 megahertz. We need to estimate rho as usual. Rho equals to FSI by FS minus FS by FSI. So 1.910 mega by 1 mega minus 1 mega by 1.910 mega. Got it? Okay. So what do you have to get then? You got the row value. The value of this will be approximately equal to maybe 1.38 around. You have to confirm me. 1.3864. Check. Once it is obtained, value of alpha root of 1 plus q square rho square equals to root of 1 plus what is the q value given? Q value is 125. Q value is 125. What is rho value? We got it here 1.3864, roughly 1.38 whole square whole square. So alpha value in this case will be standing at 173.3 roughly. Again, verify. Don't mug the answers. We have to do. Is it right? Confirm. This is for case 1. Okay. Similarly, value check. We have another case now. What is second case corresponds to? The second case, what is asked? Let us go back. Yeah, signal frequency 30 mega. Okay. Fs equal to 30 megahertz. Same process. Fsi equal to Fs plus 2 into Fif equals to Fs 30 megahertz. It is AM. So intermediate frequency is 455 kilohertz. So 30 megahertz plus 910 kilohertz. Right? How much it will be? Same. 30.910 megahertz. Alpha. Alpha. No, not alpha. We have to estimate rho. No. What is rho? 30.910 mega by 30 mega minus 30 megahertz by 30.910 megahertz, which is going to be nearly equal to, you verify once, 0.059 roughly. Okay, 0.0 5, not 5. 0.059. Okay. This is rho value. So immediately substitute alpha. Alpha equal to root of 1 plus q square rho square. So root of 1 plus 125 square into 0.059 whole square. The answer of which will be around 7.53 roughly. Maybe. I'm always